race to win wars and explore the stars, have created some of the most fantastic products ever designed, and we use them every day, unaware of their amazing origins. On Wicked Inventions. The bow, the deadly medieval weapon that now appears at the Olympics. Ferrofluid, from NASA's rockets to cooling your loudspeakers. Billiard table, the military origins of one of the world's favourite sports. We reveal the amazing science and manufacture behind these wicked inventions. The bow and arrow may be used in an exciting Olympic sport today, but this weapon system has actually existed for over 10,000 years. Probably originally developed for hunting, the bow's deadliness soon led to its adoption on the battlefield, with arguably its most effective deployment being the fearsome English Longbow of the Middle Ages. Standing at roughly the same height as its users, a group of archers equipped with this large bow could fire massed volleys of steel-tipped arrowheads with deadly effect into the enemy. Though simple in appearance, the longbow actually required great skill to be used, which meant training from a young age.
It was their life. They began to shoot by law at a very early age, some say 5, some say 7. But these youngsters would shoot for a couple of hours after church every Sunday, just to build up their muscles. And then it was their father's or guardian's responsibility to get them a bigger bow as they grew. So with regards to training, it wasn't like football training where you would go to a place to train. It was constant, it was part of your life. And a good bowman would be a bit of a celebrity in the area. And of course, worth his weight in gold, because let's face it, they could easily shoot 10 good arrows off in a minute under power, no problem.
Victory after victory against the French in the 14th century was testimony to the power of the longbow as a weapon. But what was the science behind its success?
The traditional bow and arrow basically uses a stored energy system. The stored energy is in twofold. First, it's in the actual string that's been pulled back, which is holding the bow under tension. The bow, when it's under tension, you're pulling it back and you're storing energy within the bow, because the bow would like to remain in the position it originally was before it was drawn back. That's your stored energy. When you release the string, that bow tries to immediately snap back to its original position. As it does so, the string that it's pulling on begins to pull on the arrow, and this starts to propel the arrow forward. The speed and strength of this depends greatly on the length of the bow, as well as the materials involved. Because if the materials are very stiff, if you pull it back far enough, you'll get a very, very strong, accurate and powerful shot. But if it's much more flexible, you may be able to get potentially more accuracy, but you cannot get the distance that you're looking for.
Today, modern compound bows incorporate exotic materials such as carbon fibre and pulley systems that allow the user greater accuracy when firing. But other types of bows still in production hark back to more traditional methods. For example, the laminate bow is made with layers of wood or other materials, a method that can trace its origins back to the Mongol composite bows of the 13th century. So, the bow, truly a wicked invention. Striker bows have been making longbows in Minster, Ohio since 1997.
In 1996, my dad decided to build his own bow and harvest a deer with it. So he worked on that, was able to achieve that, wanted to kind of build on that idea, so he started building a couple other designs and some for some friends. And before he knew it, some people he didn't know were asking, hey, could you build a bow for me? And that's kind of how the business started.
Their unique designs are still produced by hand and built piece by piece.
We could use a CNC, we could, automate our processes a little bit, but we choose to do it more handmade because the quality, you can tell it's handmade. Each detail is hand inspected and checked.
What's unique about them, in my opinion, is the craftsmen that work with me. I've done this for the last 18, 20 years myself, and to get the right people in the right positions to make everything happen so I can go forth with the company is pretty phenomenal. They do a fantastic job.
Every longbow starts as a block of wood. To begin, a suitable block of dyed birch wood is selected. 4 strips, or veneers, are cut from the birch block using the bandsaw. To remove the saw marks, the veneers are drum sanded down to a thickness of 30 thousandths of an inch. These veneers will be stuck together to form a strong yet flexible bow. The thickness of each veneer is checked using a dial caliper to ensure consistency. Bamboo strips are used to form the strong wood core of the bow. 2 strips will run down the length, and they are sanded to a point to form a seamless joint which can be glued together. Another birch block is selected to make the handle or riser of the bow. A template is used to mark out the shape to be cut. The riser is then cut on a bandsaw. It will be made up of 3 separate sections, separated by decorative veneers. The 3 sections of the riser are sanded on a belt sander to remove saw marks and make an even surface for gluing. Decorative green veneers are prepared to sandwich between the layers of the riser. All of the pieces are glued together using a strong epoxy resin glue. It is held together tight using clamps. Then it is put into a heat box to dry. The heat accelerates the drying process. Once dry, the riser is planed to ensure that all the veneers are flush to the surface and then sanded smooth to clean off any residue. The inner edge of the riser is then marked using a template and cut further using the bandsaw before being ground and finessed with the sander. Next, a coating of epoxy resin glue is applied to the birch veneers and bamboo cores, as well as a strip of fiberglass. The fiberglass layer will add further strength and reinforcement. The 3 layers are bonded together in a sandwich. 2 of these sandwiches will be put together to form the final bow. These 2 sandwiches are then assembled in a custom-made press surrounding the riser. The assembly is clamped tight shut, and force is applied using compressed air hose to ensure even pressure along the entire length of the bow during the setting process. The press is heated to 165 degrees Fahrenheit for an hour and a half until the glue is hardened. The bow is then sanded all over to remove any glue residue and smooth out the surface. The riser section which forms the handle of the bow is shaped and profiled using a variety of sanders. The tapered ends of the bow are also shaped. The striker logo is applied using a transfer. As a finishing touch, the manufacturing date is handwritten on the bow. The final finishing stage is to spray the bow with a protective lacquer. So, there you have it, a beautifully crafted longbow, pretty much unchanged since man started hunting. The longbow, truly a wicked invention. Unless you are an audiophile who really loves their technology as much as their music, you may never heard of this magical magnetic substance, but it was developed by NASA and might be living inside the speakers in your own home. It is ferrofluid.
A ferrofluid, as the name might suggest, is a fluid that has fine particles of iron suspended in it. This is very useful because if you pass a magnet nearby it, the particles will start to align. And if you have a stiff fluid, you can start to make the fluid react in the way that you want to. So you can turn a magnet on and off if you have an electromagnet, and so you can make the liquid jump and move about as you want.
In the early 1960s, with an eye on the future and deep space travel in mind, NASA engineer Steve Papple invented ferrofluid while researching alternative ways to control rocket fuel on board a spacecraft hurtling through space. It was hypothesized that in the weightlessness of space, and with the availability of potential free electrical energy provided by the sun, it might be possible to control the flow of fuel around a spacecraft by using electrical magnets that might be more efficient than NASA's current system of mechanical pumps. Unlike its complicated mechanical cousin, this theorized magnetic control system would have little or no moving parts. And the key to this potentially fantastic technology would be a magnetic fluid, and Pappel's ferrofluid was the answer.
In space, you have no gravity, so your fluids naturally don't just settle at the bottom of a container. You want to be able to control them. Otherwise, you could ordinarily use pressurized systems, but a magnetic system would have no moving parts and could potentially be more effective. You could use magnets to control a liquid, and if it's a very viscous liquid, it won't move anywhere. It won't evaporate, it won't go anywhere, you can choose to control it how you want. In the end, it was actually eventually abandoned because pumps and other systems could work a lot more effectively.
But that was not the end of the road for ferrofluid. Sound speakers would provide a new home for its novel characteristics. It was all to do with how a speaker works.
In order for us to hear sound, we need to have a pressure wave generated. When we speak, that is effectively what we do. We generate a pressure wave through the air, and our ears pick up that pressure wave, and we understand it as speech. In order to recreate this with a speaker, a cone exists, and this cone pulsates back and forth. All speakers have magnets in them. What happens is you have a coil of wire that goes around part of the magnet, and if you pass electrical current through a coil of wire wrapped around a magnet, that coil of wire starts to move. If you attach that wire to a cone, that'll start to move the cone back and forth, which starts to produce the pulsating air that you need in order to hear sound.
Keeping these highly vibrating pieces of kit cool was where ferrofluid would come into its own.
In order for a speaker to work, this vibration has to happen 20 to 20,000 times per second to reproduce what a human being can hear. At 20,000 times a second, that's quite fast, and that can generate potentially a lot of heat because you're cycling a lot of power back and forth through the speaker. If you put a ferrofluid around it, the ferrofluid will stay in the presence of a magnet. The magnet can act as a massive heat sink, and if the coil is passed through the ferrofluid, this ferrofluid can then act as a means of wicking away all the heat, passing it through the magnet, and then out to any other heat exchangers, so your speaker doesn't get too hot at a high power usage, while still producing the sound and the high quality that you desire.
Developed to control rocket fuel, but now used to keep speakers cool, ferrofluid. Truly a wicked invention. We've just seen how NASA's ferrofluid is a fascinating substance that utilizes the amazing characteristics of magnetism. And now it's our intrepid tester's turn. He's going to build his very own levitation device. What you will need: a flat piece of wood, some long wood screws, 2 small neodymium magnets, a drawing pin, a screwdriver, scissors, 4 ferrite speaker magnets, and some plastic sheeting. To begin, screw the 8 screws into the wood. Space them out so that 2 screws will support each magnet, which will result in 2 parallel lines of 4 screws. Leave approximately 20 centimeters between each row. Next, carefully place the speaker magnets on the nails facing each other. You will have to check the polarity of the magnets to make sure the magnets in each pair are repelling against each other and not attracting. Now, put your base to the side and cut a thin strip from the plastic sheet. It needs to be wide enough to wrap around the circumference of the neodymium magnet. Next, our tester is going to create a tube by wrapping the plastic around the small magnet. Before he does, he needs to check the magnet's polarity to make sure it faces the correct way in the tube. Lightly hold the small magnet above one of the pairs of speaker magnets and make sure you can feel it being repelled by the others. Now carefully create the tube around the magnet, leaving a 1 to 2 centimeter space at the end. Repeat the procedure at the other end of the tube. In the gap at the top of the tube, fix the drawing pin. Trying to get the balance right between the magnets is very tricky, and the drawing pin is going to be used as an anchor to stop our levitation device shooting off. We are now ready. This block of foam is going to be used as our anchor, and as you can see, cannot support the weight of the tube on its own. Let's use magnetism. Our intrepid tester carefully places the tube over the magnets with the pin gently resting against the foam. And success! Our tube is levitating just by the repelling power of the magnets. And for the cynics among you, our tester just uses his finger to balance the tube this time. And again, our tube is floating. And the science? The magnetic fields of the magnets are providing just enough force to counteract gravity, and so our tube has reached equilibrium and seems to float in midair. Brilliant! Our own magical magnetic floating tube. Billiard sports in all their forms are recognised worldwide as a great way of passing time, socialising and competing with one another. Two of the most popular forms of billiard sports are pool and snooker. But did you know of their military links and how one British Army officer played his part in the creation of the game of snooker that we know and love today? Billiard sports, or cue sports as they're also known, encompass a wide variety of skill games, usually played using cue sticks to move billiard balls around a cloth-covered table. So, where did this tradition of table sports begin?
These kind of table games have been around for hundreds and hundreds of years. We first know of instances from as early as the 14th and 15th centuries when they were played as a kind of evolution of outdoors croquet, and the green covering of the billiards table is actually there to mimic the grass of outside from when you used to play croquet. And slowly, over the years and over the centuries, this table game developed into what we would recognise today as billiards or pool.
Snooker is a hugely popular form of billiards and owes its existence to the British Army officer Neville Chamberlain.
In 1875, in the Indian town of Jubalpur, an officer named Neville Chamberlain was playing billiards in his officer's mess. At that time, a new cadet was known as a snooker, and as he was playing this game of billiards and they were trying to understand the rules, he remarked that everyone playing it were just snookers, they were novices, and the name snooker really stuck.
Since then, table sports have proved an important addition to army barracks and mess tents worldwide, giving soldiers and officers much-needed downtime and a chance to bond.
It's a very social, ordinary thing that you did at home. So it brought a human relationship into the way in which the various ranks got on together.
With snooker and pool especially growing into competitive sports played at a professional level, the equipment used must be of the highest quality, and the craft of a good billiard table has been honed over centuries. Today, slate is used on the tables to give an even playing surface.
If you're talking about a pool table, you want something that's nice and flat, but doesn't flex. And that's great, and it means that the table, if you shoot something hard, the vibrations don't necessarily pass through the table because they go straight into the ball because the cue table doesn't actually move. So you can make one shot in one corner of the table, and the balls in the other area don't vibrate or don't move.
The production of a good billiard table is a highly skilled job, giving players the perfect surface to play this ever-popular sport. Thurston Billiard Table Manufacturers are a family-run business that can trace their history back to 1799, making them the oldest billiard firm in the world.
They are certainly very durable tables. In fact, I would almost say that they last too long because we have people ringing us up these days and saying, I've got a table, a Thurston table, can you tell me any history about it? And quite often we can. We have records that have survived the bombing of the Thurston building in Leicester Square in 1940, so we can trace out, in fact, sometimes who the original customer was. So we can give a lot of history on the tables.
Today, they use tried and tested methods to produce their tables that have changed very little in 120 years, with a focus on handcrafted care and precision. The production of a Thurston table begins with the selection of the timber to be used in the construction of the frame and legs of the snooker table. Traditionally, the wood used would be mahogany, oak or walnut, though today Thurston use ethically sourced hardwood with similar properties. The wood is then cut down to the relevant sizes for the frame. Once this has been completed, the planks need to be reduced to the required thickness using a planer. In order to ensure the frame is rigidly held into place, holes are drilled into the planks and positioning dowels are fitted, as well as bolts which tighten up on nuts set into the side, middle and end rails of the frame. The legs of the table are made up of 2 units. The first is the turn leg section. This is shaped in a process called turning, which involves spinning the wood whilst the shape is chiselled out. The second section is the leg square. This has the holes for the frame dowels and bolts to fit into, before the turn section is added. The leg is then sanded to remove the turning marks and ensure it is ready for the finish, such as a polish, to be applied. It is then time to assemble the table. At this point, the table can be levelled if necessary, and any adjustments to the levelling and straightness of the table are made using a shooting plane. Once this has been done, the slate bed can be fitted. There are 5 sections of slate to make up the bed of the table. The slate is imported finished, ready to be installed onto the table. When assembled, the slate bed is 12 feet long, over 6 feet wide and 1 3/4 inches thick, and weighs a whopping 1 ton.
The thing about making a table is it combines quite a number of different requirements, from woodworking to upholstery work, handling rubber, etc. So it is quite a skilled job just making the table, and equally it's a very skilled job to erect the table to make sure that it is level and everything runs correctly so that the balls don't wander off down the table when the shots are played.
After this slate has been fitted, the table is dismantled and the frame is then sprayed to the colour requested by the customer. The table cushions into which the rubber section has been fitted require careful and precise cutting of the rubber for the pocket openings. A template is used to ensure that the shape is correct and will match with the pocket templates used to check pocket openings for match play. The cushion can then be fitted with pure wool billiard cloth. This is a highly skilled job, as it is important to ensure that the nose of the rubber is kept level and the cloth is completely smooth and wrinkle-free. The pocket leathers are then fitted to the brass pocket plates and the pocket nets are sewn on. Once this is completed, the tablecloth is tacked into place. Again, careful attention is paid to ensure the cloth is smooth and tight. The table is marked out to regulation measurements and then ironed one last time. The final stage of the production of a Thurston table is to fit the cushions. Once this is complete, the billiard table is ready to play.
From start to finish to make a table, we can do it easily within a week. Tables these days tend to be being made bespoke, that we will wait for the customer to come along, so they'll tell us what colour they want the woodwork. Sometimes they can even select the timber, so we might use a mahogany type timber, which will be traditional, or even something like maple if it will fit their room. But the table itself, basically turning the legs, making the woodwork, checking the slates over, fitting the cushions, making sure that the cushion height and the rubber, etc. is the right height. To do it properly, about a week.
Centuries old and still as popular with players worldwide as ever, the billiard table is truly a wicked invention. So there you have it. A dash through the hidden history, super science and amazing manufacture of products that you use every day, but have never realised their amazing background. The bow, ferrofluid and billiard tables, all wicked inventions.